Hello everyone and welcome to the channel Chemistry Without Cramming, a bowl of chemistry knowledge. My name is Agnes and I'm here to convince you that chemistry does not have to be difficult. I would like to help each of you, especially those for whom chemistry class is a weak point. The topic of this video is the molar concentration of a solution. There will be some theory and then step-by-step walkthrough of 5 sample problems. Okay, let's start. Molar concentration, molarity, is the number of moles of a solute dissolved in 1 liter of a solution. Molar concentration equals the number of moles of solute divided by the volume of a solution. The unit used for this concentration is mole over liter or mole per cubic decimeter. I would like to remind you that 1 liter equals 1 cubic decimeter equals 1000 milliliters equals 1000 cubic centimeters. What is a mole? 1 mole is defined as the amount of a substance that contains the same number of elementary entities as there are atoms in 12 grams of C12 isotope of carbon. This number is expressed by the Avogadro constant. Avogadro's number is the number of particles in 1 mole of any substance. For example, 1 mole of copper weighs 63.5 grams. How to calculate the number of moles? To calculate the number of moles of any substance in the sample, we simply divide the weight of the substance by its molar mass. How do we calculate the molar mass of compounds? We calculate the molar mass of sodium chloride by adding together the molar masses of 1 atom of sodium and 1 atom of chlorine. So, to calculate the molar mass of the compound, we need to sum all of the molar masses of the elements in the molecule. We can always find the value of atomic mass of each of the elements in the periodic table. Generally, solving problems regarding the molarity of solutions is based on 2 formulas. Practical note: when the symbol M is accompanied by a numerical value, it is read as molar. For example, a solution labeled 2M potassium hydroxide is read as 2 molar potassium hydroxide. In this case, molarity of potassium hydroxide equals 2 mole per liter. Okay, enough the theory, time for the problems. Problem number 1. Calculate the molar concentration of the solution, knowing that 10 moles of the substance were dissolved in 5 liters of the solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of the solution and number of moles of solute. We are looking for molarity of the solution. Molarity equals the number of moles of solute divided by the volume of solution. So 10 moles divided by 5 liters equals 2 moles per liter. Answer: the molar concentration, molarity of the solution, equals 2 mole per liter. Now problem number 2. In 4 liters of the solution, there is 14.9 grams of potassium chloride. Calculate the molar concentration of the solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of the solution and weight of salt. We are looking for molarity of the solution. First point, we need to calculate the molar mass of potassium chloride. We read the atomic mass of chlorine and potassium from the periodic table. So molar mass of potassium chloride equals molar mass of potassium plus molar mass of chlorine equals 74.5 grams per mole. Now we know that each mole of potassium chloride weighs 74.5 grams. I will write down the molar mass of the potassium chloride data under the problem data for two reasons. First reason, I have limited space to present the next stages of solving the problem. Second reason, by writing it this way, we know clearly what information has been provided already and what still needs to be calculated. Second point, we need to convert the mass, weight, into the number of moles. The number of moles of potassium chloride equals weight of the salt divided by its molar mass. You can see that the grams cancel out and we get the result in moles. So the number of moles of potassium chloride equals 0.2 moles. I write down the number of moles of the potassium chloride under the problem data. Finally, we are ready to calculate the molarity of the solution. Molarity of our solution equals the numbers of moles of potassium chloride divided by volume of the solution. So molar concentration of the solution equals 0.05 mole per liter. Therefore, we already had the answer to our problem. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. And now let's go to problem number 3. Problem number 3. How many grams of sodium nitrate are in 250 grams cubic centimeters of a solution with a molar concentration 2 mole per liter? Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume and molarity of the solution, and we are looking for weight of sodium nitrate. We need to remember that 1 liter equals 1000 cubic centimeters. To convert cubic centimeters to liter, divide the numerical value of cubic centimeters by 1000. In other words, move the decimal point by 3 places. If you are not sure whether you should divide or multiply the value given in cubic centimeters, you can write down the proportion. 1 liter corresponds to 1000 cubic centimeters, so x liter corresponds to 250 cubic centimeters. We calculate x by cross-multiplying this proportion, so 1000 cubic centimeters times x equals 1 liter times 250 cubic centimeters. To solve for x, we need to divide both sides by 1000 cubic centimeters, so it follows that x equals 1 liter times 250 cubic centimeters over 1000 cubic centimeters. You can see that the cubic centimeters and 10 cancel out here, and we get the results in liters. So x equals 0.25 liters. Okay, let's get back to the problem. First step, we need to calculate the molar mass of sodium nitrate. We read the atomic mass of sodium, nitrogen and oxygen from the periodic table and write them as molar masses. So molar mass of sodium nitrate equals molar mass of sodium plus molar mass of nitrogen plus molar mass of oxygen times 3 equals 85 grams per mole. Now we know that each mole of sodium nitrate weighs 85 grams. Let's write the molar mass of sodium nitrate under the data in the problem. Now we need to calculate the number of moles of sodium nitrate in this solution. Molarity equals the number of moles of the solute over volume of the solution. We have to transform this formula for number of moles. How to do it? For example, we can use the popular triangle method to transform our formula. Now we know that the number of moles of solute equals molarity multiplied by the volume of the solution. In our case, the number of the moles of sodium nitrate equals 2 moles per liter multiplied by 0.25 liter. We can see that the liter cancel out here and we get the result in moles. Now we know that there is 0.5 mole of sodium nitrate in our solution. Let's write the number of mole of sodium nitrate under the data in the problem. Finally, we are ready to calculate the weight of sodium nitrate in this solution. The number of moles of substance is equal to the weight of the substance divided by its molar mass. After transforming the formula, we get that the weight equals the number of moles multiplied by the molar mass. In our case, weight of sodium nitrate equals 0.5 mole multiplied by 85 grams per mole. We can see that the moles cancel out here and we get the result in grams. So now we have the answer to our problem. This solution contains 42.5 grams of sodium nitrate. Problem number 4. What volume of a calcium chloride solution with a molar concentration of 0.25 moles per liter contains 2.775 grams of calcium chloride? Let's start by writing down what we know and what we need to calculate in this problem. We know already the weight of salt and molarity of the solution, and we are looking for the volume of the solution. We need to calculate the molar mass of calcium chloride. We read the atomic mass of calcium and chlorine from the periodic table and write them as a molar masses. So molar mass of calcium chloride equals molar mass of calcium plus molar mass of chlorine times 2 equals 111 grams per mole. Now we know that each mole of calcium chloride weighs 111 grams. Let's write the molar mass of calcium chloride under the data in the problem. Let's go to the second step. We need to calculate the number of moles of solute. To calculate the number of moles of any substance in the sample, we simply divide the weight of the substance by its molar mass. In our case, we got 0.025 moles of calcium chloride. Let's write the number of mole of calcium chloride under the data in the problem. Finally, we are ready for last step. Now we can calculate the volume of the solution. Molarity equals the number of moles divided by the volume of the solution. So after transformation of this formula, the volume of the solution equals the number of moles of calcium chloride divided by molarity of the solution. In our case, it is 0.025 mole divided by 0.25 mole per liter. We can see that the moles cancel out here and we get the result in liters. The answer for this problem is this volume equals 0.1 liter. Problem number 5. A student evaporated 100 milliliters of water from 300 milliliters of sodium hydroxide solution with a molar concentration of 0.5 mole per liter. Calculate the molar concentration of the resulting solution. Let's start by writing down what we know and what we need to calculate in this problem. We know already the volume of solution 1 and volume of evaporated water. And also we know the value of molarity of the solution 1. We are looking for the molarity of the solution 2. Our data shows that we have to convert the volume from milliliters to liter. So 300 milliliters equals 0.3 liters and 100 milliliters equals 0.1 liter. Let's represent this with the help of the drawing. In the beginning, we have an initial solution in a glass dish with a volume of 0.3 liter and molarity 0.5 mol per liter. Then 0.1 liter of water is evaporated from this solution and we obtain a new final solution. The volume of the final solution is equal to the volume of the initial solution minus 0.1 liter, so minus the volume of evaporated water. In this problem, we need to calculate molarity of the final solution. Step first, we calculate the number of moles of sodium hydroxide in the initial and therefore in the final solution. Number of moles of sodium hydroxide equals molarity of solution times volume of the solution. In this case, you can see that the liters cancel out here and we get the result in moles. Let's represent this with the help of the drawing. In the initial solution, we have 0.15 moles of sodium hydroxide, and in the final solution, we have also same amount of moles of sodium hydroxide. Why same? When we evaporate a solvent, in this case water, the number of moles of solute does not change. Now we are ready to calculate molarity of the final solution. Molarity equals the number of moles divided by the volume of the solution. So we got answer. Molar concentration of the final solution equals 0.75 mol per liter. Guys, that was the last problem from this subject. Finally, as usual, problems for those interested, titled Check Yourself. Answer for these problems you can find in the video description. Guys, that's all for today. Thank you very much for your attention. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. Thank you very much for your attention and see you in the next video of Chemistry Without Cramming, a Bowl of Chemistry Knowledge.